my breath for a second.
There we go. All right, go ahead, David.
Sure. So as I was saying, the Thompson Brook is shown here, coming south, although you can see that there's a number of very classic meanders. So it's moving this direction, coming back this direction, right? It's moving quite a bit. And that's because it's not constrained by that same nick point that the Farmington River is constrained by. It's eroding into these areas quite a bit, and creating oxbow water areas as well, here and down here as well. So it's a very active and meandering stream. And we now know that it has migrated, this meander has been happening for quite some time, and it has meandered or migrated south over time. So here in red, we can see a fluvial channel. It's very clear. This is the base of the Thompson Brook at one point. These are stream terraces on either side. Here we have it again in blue, maybe not as clear, but it's still there. And then again in green here as well. Again, a very clear river channel as well. This is really exciting because it shows that the Thompson Brook at some point was probably over here and has moved south over time. And it was at one point very close to those site boundaries that we were talking about where the levee exists here, but it doesn't really exist over here. And this, the emptying of the Thompson Brook into the Farmington River is important. During large flood events, like the one that happened last year here in Avon, if the Thompson Brook was closer here, it would have been flooding around the same time as the Farmington River. And what happens is the flooding of this Thompson Brook acts as a sort of debris shield that pushes sediment and force out into the river, and then physically pushes the movement of the water in the Farmington River to the right. Okay, so it's not the channel itself doesn't move, but the movement you can see here, the river flow, is forced to the right of the debris fan and the debris flow. And if this brook was here about 12,000 years ago, it would have actively protected and acted as a shield for this landform. So that's really important because it suggests that we have two things happening here. We have the nick point farther downstream and this debris fan that are both acting to protect the site. And it suggests that if we can find similar nick points and similar debris fans on other rivers, we can probably find other Paleo-Indian sites that may be deeply buried. And if they're deeply buried, they're going to be well preserved, such as this one. So this is a really, really important discovery that was made in this state register nomination that maybe isn't as exciting to look at as some of the stone tools that we'll show in a minute, but is really important for understanding where these sites may be and protecting them and excavating them and learning more about the past. So that's some of the newer ground penetrating radar and soil coring research that has been going on. I'll go over the excavation strategy to introduce sort of what happened in 2019 with the excavations and set up some of the artifacts that were found, and then turn it over to Dr. Heffter. So as we've said a couple of times, the site was discovered in 2019, buried 150 centimeters below the modern ground surface. The work was funded by DOT. This is a GoPro. It's not a video, it's like a picture taken like every half second of excavations that happened in this block here. We excavated initially 83 shovel test pits, which are these small 50 by 50 centimeter squares. This was expanded to 210 1 by 1 meter excavation units, which you see the much larger plan here. There were only about 224 artifacts found in the shovel test pits, a couple of pieces of charcoal, maybe one feature. I'll start that again. And one tool, a piece ESK, which is a wedge, a tool that's used to split bone or wood to shape other artifacts. When we did the 210 excavation units, we found over 16,000 artifacts from these meters, including a range of stone tools such as these here. This is a basic Paleo-Indian toolkit of side scrapers, end scrapers, a broken projectile point, some of those wedges that I was talking about, a graver, something that is used maybe to make bone needles. We don't really know what it's used for. And we found over 20,000 charred ecofacts that I think Dr. Heffter will talk a little bit about. So really a wealth of data was discovered in these larger excavation units, including a high number of cultural features, such as large hearths or open fire pits, as well as posts that may have been from domestic structures or some other structure. What did this look like when we were excavating it? These are the soil profiles. So this is the original ground surface with the nice little grass here. That's the Holocene alluvium, ALV 0, 1, 2, 3, and 4. I mentioned before, we just gave these nomenclature to the soils as we excavated them so we could keep track of the different sediment packages and those that had artifacts within them. The site was found on that crest of the levee that I talked about. You can see it's exaggerated here, associated with the Farmington River flooding. The Paleo-Indian and early Archaic occupations are in ALV 0, ALV 1, and ALV 2, maybe a little bit in the bottom of HALV, but the middle woodland site is here at the top of the HALV sediments. As some of you may know, we got a radiocarbon date from one of those features, a hearth here, feature 2, while we were in the field. It's a charred pine wood fragment. The botanical analysts that we work with know that it's a pine fragment based on these vacuoles for sap that they can look at under high microscopy here. This was sent for a radiocarbon date. We got back a 10,520 plus or minus 30 years. That's an uncalibrated date, so 10,500 years ago. When you calibrate that to the calendar, radiocarbon dates don't equal calendar years, and that's because it's complicated, but it's because the input of solar energy that creates the unstable carbon or the radiocarbon in the atmosphere is not, that input of solar radiation is not stable. And so the farther in time you go backwards, the more removed the radiocarbon date is from the calendar. When we calibrate this based on tree ring dating, it comes to 12,665 to 12,475, or about 12,547 years ago. That, when it was discovered in 2019, was the oldest date associated with humans in southern New England. There's one date that's slightly older in northern New England. Since then, we've dated a number of other cultural features that you see here, one of which came back as slightly older than feature, two of which are older than feature 2. One is a little bit older to 12,700 years old. But what we've found is that there are a range of different dates. We have 3 dates that date to what's called the early Paleo-Indian period. We have 4 that date to the early/middle Paleo-Indian period, and then a number here, 7 that date to the middle Paleo-Indian period, a few to the late Paleo-Indian period, and a few to the early Archaic period. This indicates that there were 6, possibly 7 occupations between 12,650 and 8,000 years ago at the site, which is an incredible record of people being in the same location, coming back to a really good place to camp for over 4,000 years. Based on the features, the hearth post, there is a peak in occupational intensity at about 12,300 years old. I misspoke earlier, 9 separate dates to the middle Paleo-Indian period, which are mostly centered down here and up here. And so I'm going to just quickly go through a little bit about the artifacts and then turn it over to Dr. Heffter. The artifacts themselves, the stone tools, are typical of Paleo-Indian sites in the Northeast. We have chert or stone tools that come from Normanskill, New York, here. Hardyston Jasper from Pennsylvania, here. Some of it's red as well. Trap Rock Chalcedony, which is local. Hornfells from north central Connecticut. We have banded rhyolite, which could be from northern New Hampshire, but may also be from Massachusetts. We have what's referred to as Indian River chert. This is also from the Hudson River Valley. It's this red chert here. We have some cobble chert that's from the river that has a little bit of jasper in it. It could be local. It could also be from Pennsylvania. And we have quartz that is most definitely local. So what does that look like if we go back to the excavations? Well, the Norman Skill chert from the Hudson River Valley swamps the rest of the artifacts that have been found. These are contour maps to show where the concentrations of Norman Skill chert are. You can see that they are very clearly in the northern part of the site, again, suggesting that the site clearly extends outside of where we excavated. You can see that some of the highest concentrations are here, moving north outside of our excavation area. Hardest and Jasper, much smaller number, 762 pieces, although very tightly spatially organized here and here. The rhyolite, even tighter in spatial organization here to the top left. Trap rock chalcedony, mostly situated here to the bottom right. There's some here as well. This is not real. It ends here. It's just a factor of the contouring. The Hornfells, which is also local, is all situated in the southern part of the site. And then the quartz is mostly in the northern part of the site here. And so what do some of these artifacts look like? These are a range of the channel flakes that were found. Channel flakes are important because these are not tools themselves, but they are diagnostic to a specific type of spear point that only Paleo-Indians made. And so these are the fluted, the final thing that Paleo-Indians removed from a spear point when they made it, the flute or the channel flake, so that they could easily haft that spear to that spear point to a spear shaft. So a number of these, over 80 were found. Many of them refit as well, suggesting that we have really good site integrity because they haven't moved very far over time. Bifaces, these are, so if we go back to the channel flakes, these are the last stage in spear point production. Bifaces are a much earlier stage in spear point production. These are late stage bifaces here, the top four, some earlier stage bifaces down here. Again, what they're doing is creating spear points, but this isn't the final product. This is more the mid-stage product. We have projectile point fragments. Most of these are base fragments here that have broken off, probably during hunting. The spear point breaks off in an animal. You bring the animal back to your camp near the hearth. We can see that a number of them are found close to hearths here, here, and here. And then as you're butchering that animal, you remove those spear points and maybe sort of toss them behind you. Or maybe they break during manufacture and you also toss them behind you or in front of you in anger at breaking something that you spent a lot of time making. We have a number of side scrapers that were found. These are used to scrape fresh hides after you've killed an animal to create clothing or camping material, or maybe they're used to scrape old hides because you're trying to get a little bit more use out of this hide at the end of the winter too. I think Eric will talk a little bit about that, but some of the useware results that we have from some of these scrapers. We have a number of end scrapers. These are also used to scrape hides. They're really specialized tools that you attach to a bone handle or a wooden handle to, again, scrape hides to create that camping or clothing material. Again, remember, this is the Ice Age. It's very cold. Not that it's not uncold here in Connecticut in the winter already, but colder, certainly during the Pleistocene. A number of those wedges here used to split bone and wooden tools. Most of those are found down here, although a couple are found sort of throughout the site as well. And then a number of gravers. Again, these really tiny points here that we're not really sure what those are used for. Possibly used to decorate or score bone or wooden tools, maybe used to perforate bone needles. Again, we know that sewing clothing and camping equipment would have been critically important for people. That's not a horrible idea, but again, we don't really know what they were used for, as well as some curved artifacts here, which were used to shape wooden or bone artifacts, as well as sort of a spoke shave to straighten maybe spear points or other hunting equipment. And then a number of, this swamps the rest of the tools, utilize flakes. That's just a term for very quick, sort of like Swiss Army knife like type artifacts that are quickly produced, that are sharp, that you use to cut meat, sinew, maybe hides, maybe wood things. So your sort of day-to-day artifacts that you're using for a number of purposes. So that's just a quick overview of the work that's been done over the last couple of years, some of the artifacts that were found, and what the excavation strategy was. And I'm going to now stop sharing and turn it over to Dr. Heffter.
Oh, thank you, Dr. Leslie. Let me just try to share my screen here. There we go. Okay. All right, so I actually started at Archaeological and Historic Services in July of 2021. And before that, I was in graduate school at the University of Arizona. And what was interesting was just randomly in January of 2019, I was back here in Connecticut. I get a call probably like around February or so from Dr. Leslie saying, hey, we have this really cool site. We need to excavate it as quickly as possible. Would you be interested in doing some work? And it's like, yeah, that'd be great. I could really use some money. And I had no idea what to expect. And I helped excavate the site for a few weeks. And I mean, I was just blown away by it. I mean, this is something that really is a once in a lifetime opportunity, a once in a lifetime site. And I mean, it's just unbelievable that it was discovered. So I would have not thought that, 2 or 3 years later, that I would also be involved with some of the research after the excavation began. And so I'm just going to give a bit of a research update. Again, just the location of the site. It's in the Farmington River Valley. Dr. Leslie did a really good job summarizing a lot of the results from last year in his presentation that he gave last year. And needless to say, the amount of research, the kinds of research that have been done is absolutely incredible. I mean, these kinds of projects, normally, maybe you do 1 or 2 things, like you maybe get some radiocarbon dates so you can figure out how old the site is. Maybe you do some analysis of the charred materials that you find. But here, I mean, it's, you have radiocarbon dating, you have protein residue analysis, lithic use wear analysis, petrographic analysis, site formation processes, GPR, macrobotanical analysis, spatial analysis. And what's great about not just the amount of research, but when you have these sorts of things, they start to integrate together and can tell you more than any individual result could. So it's an absolutely incredible data set to work with. So again, sort of the very quick highlights from last year. This is the oldest securely dated site in southern New England. We have at least over 20 radiocarbon dates. They show us many different periods of occupation. It's very unusual to have this many radiocarbon dates from an archaeological site of this age. So this is probably one of the most well-dated Paleo-Indian sites in the Northeast, perhaps east of the Mississippi River even. I mean, it's just incredible. Dr. Leslie, gave some more detail on using GPR to understand the site formation processes, which is crucial to also kind of understand the context of the site, and also will provide us, valuable data for where we could find other sites in the future. Basically, some of the use wear, as we kind of discussed briefly, we have evidence of hide scraping, scraping wood. Perhaps one of the probably one of the coolest results though from last year was the protein residue analysis. This is a stone tool was taken. It was, analyzed for protein residue from animals that perhaps were killed on it, the blood residue from them. And there were, a lot of kind of different animals, but the most exciting one was protein residue that's associated with the elephant family. And there's no elephants during that time, of course. So it really can only be mammoth or mastodon. And that's just incredible because it basically means that, there is mammoth, mastodons, and humans sort of together in the Northeast at the time, which was something that was very difficult to confirm before. So already, amazing results. And in fact, so many kind of results that right now we're sort of at the stage where we're sort of now integrating results more than sort of getting kind of like new, fresher results. That being said, I'm going to present some research results on micromorphology, on a pendant that was recovered from the excavations, and also talk a little bit about ochre that was found at the site. So the first thing is talking about soil micromorphology. So what this is you examine soil at a microscopic level. And so there are things that you can see in the soil under a microscope that tell you about how it was formed, things that have happened to it afterwards that you just simply don't see when you're looking at a normal soil column. And so what I have here are just, some pictures. These boxes here are actually micromorphology samples. So what you do is you have sort of a sediment profile, and you basically just kind of jam the box into there. You then take out the sediment sample, wrap it up very carefully. Then what you do is you actually impregnate it with some sort of plastic or resin. Once that resin has, dried, you then make very little slices, very thin slices out of it. And then what you can do with these slices is you can look at them under the microscope, and there are certain properties of them that tell you about how the soil has formed and what has affected the soil over time. And so from an archaeological perspective, this can also tell us things about, there might be, let's say, a living floor that would just be too hard to see with normal excavation and analysis techniques. Whereas here, we have the potential to see it. And so from these results, the analysis was performed by Dr. Ami Chittum, and 8 samples are from non-archaeological sediments, and 6 samples are from archaeological sediments, features. And so what I mean by non-archaeological sediments is basically just the natural soil stratigraphy that Dr. Leslie was talking about earlier. And so this can kind of, tell us properties about the soil that have nothing to do with the archaeology per se, but at least provide good context for sort of how the site formed over time. And here's actually one of the micromorphology samples here on the right. It is definitely one of those things where it takes a long time to sort of understand what exactly you're looking at. I'll be honest, I am not a soil micromorphologist, so I'm going to have to rely on the experts here. But overall, based on the results of the samples, we get some really cool results. The first thing is that based on the properties of the sediment itself, it's very well preserved. So, we have round sediment grains, small size of particles. So what this means is, as Dr. Leslie was talking about, slow, basically alluvial deposition, but it's very slow. If you were having sort of like a catastrophic flooding event, you would expect there to be all sorts of different sizes of sediment particles, in this sort of micromorph sample. Bioturbation, this is basically soil moves around through the actions of earthworms, other burrowing animals, rodents. And it's one of those things where you really can't appreciate it until you actually see it, like on an archaeological excavation or something. It's absolutely astonishing how much animals actually, affect sort of the natural order of soil. So for sure, at a site this age, bioturbation is going to be present, but it's at manageable levels. The same thing with frost, freeze, thaw damage. So, kind of like with a road, soil will sort of freeze and it'll thaw, so it'll expand and contract. And depending on how that happens, you can actually sort of have these kind of like wedges or, uplifts of soil in certain parts. So again, not really surprising about that for the time period. Probably what's important too is, based on sort of the micromorphology results, we sort of see that there's weathering in place. And what so this basically means is that these sediments were deposited very slowly. if they were deposited kind of all at once, you you wouldn't really see this kind of weathering in place. And I would say the most important thing, of course, is there's no evidence of major flooding events. As Dr. Leslie was talking about, based on the GPR data, that makes complete sense. And it is really nice when you have different kinds of analyses that are looking at the same issue, but from different angles, and then they sort of complement each other. So we don't have to just rely on the GPR data to tell us that this site is well preserved, that there's slow deposition and stuff like that. We also have the micromorphology data to tell us that. So, I mean, we're completely sure about this, and it's just remarkable. And just sort of the kind of implication of this, the low energy alluvial environment helps explain site preservation. The sediments are pretty well reserved. And this is protected from large scale flooding, which, aside from the fact that that means that the archaeological site is preserved, I have no doubt in my mind that this was a preferred site location, that people chose this area on purpose and probably kept coming back to it because of its favorable location. So the next thing is the archaeological features, the cultural features. And so when we talk about features, what we mean is, unlike artifacts, like say a stone tool, which we can remove from the archaeological site and bring back to the lab, cultural features are things that we really can't remove. Now, what we can do is we can take like a soil sample, or even, depending on the size, all of the sample of the feature. But that may not always be possible. So it's just a terminology for those sorts of things that are kind of immovable, like parts of the site. And so the micromorphology samples here deal with different types of features. We have, let's see here, several different features. Feature 2, which is a large hearth from the early Paleo-Indian period. We have feature 3, a post-mold and a post-hole, which was not radiocarbon dated. Feature 6E, which was a hearth, 6C, which is a hearth, 6E, which is a post-mold, and 10, which is another hearth. So we have a very good sort of range of types, and also from different time periods. And I think one of the important things is that, the natural stratigraphic, the natural sediment samples kind of act as a control in comparison to these archaeological samples. So what we can see in the results is that there's a clear difference in the sediments between the feature and the natural sediments. There's also evidence of bioturbation, which again is expected, but crucially, the micromorph data has shown that there is cultural material that would have been too small to really see with the naked eye. These are things like charcoal, burned bone, even very, very tiny flakes that are present in these feature samples. So this just further, confirms the cultural nature of these features and also sort of their intactness. The next thing that I'm going to talk about is a pendant that was found on site. So you can see it here. It's actually a fragment of a pendant. And this was found near 2 features dating to the early or middle Paleo-Indian period. The person who did the analysis was Logan Miller at the Illinois State University. He's also the person who collaborates with AHS on the use-ware analysis. And basically the results that he was able to find is that the hole that the pendant, or the hole that, makes us believe is a pendant, was created from human manufacture. And this is really important because there are times with archaeological sites, with artifacts, that natural things can actually create things that look like they've actually been made by humans. And so through the analysis, this, in comparison to, let's say, other pendants, the basic results are consistent with other pendants that are manufactured by people. And one of the other kind of questions is, okay, if it's a pendant, there's a hole there. Is this something that was worn? Is this something that was worn around somebody's neck? If so, it's sometimes possible to actually see little tiny bits of wear from someone just having that pendant like around them for a very long time. Unfortunately, there wasn't any evidence of polish, but what's important to point out here is that one of the other things that Logan Miller did was actually created its own experimental pendant, wore it for basically wore it and walked for about 25 miles or so, to see if like any sort of polish would develop at that point. And so in that experimental pendant, even though it was something that was worn, it was something that I walked around with, there was no polish on it. And other archaeologists have sort of thought that, they've done kind of their own experimental research, and they've sort of found that it may take as long as 6 months or so for any sort of like polish to be, visible on these sorts of things. So it's very possible that this pendant was in fact worn, suspended, but it just wasn't worn long enough to have any sorts of traces available. But still just amazing, especially too, because, there's still some, I think, debate about whether or not these kinds of personal ornaments were, common for Paleo-Indians. I have no doubt in my mind that they are. That's based a lot kind of on sort of before I came to AHS and started doing CRM. My research was in Europe on the Upper Paleolithic. So we're talking about like modern humans about 40,000 years ago. And, these kinds of personal adornments are things that we find all the time. These are not unusual at all. So there's no doubt in my mind that Paleo-Indians also had it. It's just possible that we either don't recognize it, or maybe that these are things that are kind of difficult to see in the archaeological record. But still, also because of the numerous radiocarbon dates, we're able to establish the antiquity of this pendant. Without those radiocarbon dates, it might be a bit more difficult to convince people of this. And then finally, I'm just going to talk a little bit about ochre. This is, red or yellow pigment. Ochre actually has been found at archaeological sites for tens, if not hundreds of thousands of years, maybe even as far back as 250 to 300,000 years ago. So we're not even talking about like modern humans or us per se. We're talking about, like Neanderthals, maybe even earlier hominins. So this is something that, use of ochre is, integral to humanity, let's say. And ochre has several kind of different uses. So of course you can use it as a pigment. So you can use it in painting. So this is from El Miran Cave in Spain. This is very famous cave art that a lot of people have probably seen. It also has very important ritual use. So in the context of burials or other sorts of ceremonies, you may find artifacts or even bones that are sort of, covered with red ochre. There's, obviously some sort of ritual significance there. And then also too, there's more sort of common uses for it. So it's an ingredient for the creation of an adhesive. And so this might have been useful in the past for helping to haft projectile points to, spears or something like that. So a lot of different uses for it, and certainly not exclusive, mutually exclusive. You could, have one site that has all of these different things. And so what's really cool is that we have quite a lot of ochre that we've recovered here. And so the most notable, ochre feature is this feature 29 here, which is just, a very large ochre stain. But we also collected ochre from other areas. And, you can find it, it's possible that we found some pieces that, were collected outside the features, but these archaeological features, the ones that we have radiocarbon dated, we can definitely say like, okay, here's some ochre and it's in a feature that is, intact and it has X and Y date on it. And so what we see here is that ochre is found extensively throughout the site, but also too, it's found in basically all the different Paleo-Indian periods. So, I mean, this is kind of more of a symbolic thing. These stars just represent a particular feature that has ochre in it. And you can see that, early, middle, late Paleo-Indian, there's ochre around all of it. So clearly ochre was important in Paleo-Indian lifeways. So at this point, I'm going to kind of discuss some future research that we're going to do over the next year. So a lot of the actual analyses have sort of been done. And what we're going to be focusing now on is integrating all of this, all these different lines of evidence, all these different types of data, and try to come up with like a really good, story. And this is something that is going to take many years. And what we're probably going to focus on over the next year is sort of the analysis of the lithic technology, of these stone tools that we've recovered. So Dr. Leslie showed earlier sort of the different like tool types that we found, at the Brian Jones site. But also too, just knowing about the tool itself, it's really cool. The use where it can tell us what it was used for perhaps. But, when it comes to archaeological sites, most of the material that we collect is actually not those stone tools themselves, but all of the like little pieces that were taken off to make those. And so, I just have a photo that I took off the internet out here that, basically shows this, all these like small pieces to, kind of create bifaces or points. We call this debitage. And, this is what we actually use to sort of, do a lot of stone tool or lithic analysis. And it tells us things, of course, what raw material they were using and therefore where the raw material was coming from. It tells us things too, also about, how they're selecting stuff, but it also tells us a bit about mobility, how people are moving about the landscape, and also too sort of site uses and things like that. So it's going to get a little bit into the weeds here, but there are certain things that'll tell us kind of important information about mobility and how people were sort of using these materials. And one of the first things is something called cortex coverage. And so all cortex is just kind of a fancy term for this sort of outer rind that's found on different kinds of raw materials. And this outer rind may not look like anything, but it's actually super important because this is from weathering. And what basically happens is, you can imagine that you have a very large piece of rock. A lot of times you really don't need all of that rock in order to make a stone tool. So what you do is you go to a raw material source, and instead of, picking up an entire large boulder or something, you can just knock off a few small pieces to create flakes, which you can then later bring back to wherever you're living. And then you can turn those into stone tools. And what you're probably doing is, if you're doing that, you're not going to really be taking these pieces with a lot of cortex. So these pieces that you would take off that would have cortex on them, these will be left at basically where you got your raw material from, a quarry or something like that. And then when you bring sort of the material that you wanted back to the site that you're living on, when we sort of see the debitage that's left behind, we're not going to see much evidence of, this kind of cortex. And what you can basically say is that if there's raw material that's more numerous, that's closer to where you are, there's probably a better chance that there's going to be stuff with more cortex on it that we'll find at a site, as opposed to stuff that's further away. And so just over here, I have a very kind of quick graph that shows cortex proportions amongst the different types of raw material that we have found at the Brian Jones site. And so, the actual numbers of these proportions are not so important as much as sort of the general trend or the difference between sort of the cortex proportions between these different raw material types. And so, for example, these raw material types that are highlighted, that are circled, these are non-local or quote unquote exotic raw materials. So, as Dr. Leslie was talking about, we have jasper that's from Pennsylvania, we have chert from upstate New York, we have rhyolite from either New Hampshire, the Boston Basin. And so this is stuff that's pretty far away. So you would expect this stuff to have much less cortex on it, because if it's coming that far away, either, whoever is inhabiting the site has gone there, or they have gotten it through trade or something like that. And so you're not going to take, like a huge cobbles with you. You're going to be taking like smaller flakes that you can fashion into tools to arrive on site. And so that's what we see. You know, we basically see here that sort of the more non-local raw material, the stuff that's further away, has a lot less cortex on it than stuff that's local. I mean, especially, you know, quartz, for example, which is very local and located pretty much everywhere. And so you have sort of a high amount of cortex on that. You know, same with the hornfelds and the chalcedony. So that's pretty interesting there. And then also too, just talking about this debitage, sort of all those different pieces that are taken off in order to make a tool. So what I have highlighted here is you can see kind of these removals on these tools. You know, those negatives are actually tiny little pieces of debitage that have been taken off them in order to like make them. And so these are things that are left behind it at archaeological sites. I mean, this is literally trash, but it tells us important data about how people are making stone tools. And so in this pie chart over here, this is basically, you know, the artifacts that we collected, or count of artifacts we collected from the Brian Jones site. I don't have the stone tools on here, but there's at least 200 stone tools, basically, you know, these things here that we collected from the site. However, the vast majority of the lithics that we collected, the lithic artifacts we collected, are these debitage, you know, debitage, these things that, you know, are removed from tools. And what's particularly interesting is the breakdown of this debitage. And so without going into too much detail here, you know, things like flakes, for example, these here, they're fashioned into tools, but the actual sort of main like body of them are flakes. So, you know, we can see here that there were definitely these sorts of flake blanks around that people could then refashion into actual formal stone tools. What we also see too is microflakes, retouch, resharpening debitage. So these are going to be like small, you know, kind of pieces that you're taking off to kind of, you know, renew an edge, make some other like modification to a stone tool. So in terms of the number of artifacts that this creates, it's actually quite numerous, but the actual size is, we're talking about things that are really small, like, you know, maybe half an inch, if that. And so the vast majority of the assemblage is made up of these microflakes, these resharpening flakes. And this shows us that, you know, there's tool manufacture, there's tool maintenance going on here. But what's most interesting is this thing here called primary reduction debitage. And it's just this little piece here. There's, I think, 125 pieces. And what this is just a fancy term for pieces of stone that have been removed that still have some of this cortex. And so what it basically means is that, you know, if you have a lot of these kinds of primary reduction pieces, you know, in an archaeological site that, you know, you're excavating, it means that you're either kind of like, maybe you're at a quarry site or you're very close to a quarry. People are bringing material from not very far away, and then they're just reducing it there. On the other hand, though, if you don't have much of this primary reduction debitage, what it means is that this stuff is probably coming from, you know, far away. And so this kind of fits with some of the other lines of evidence we have for Brian Jones site, where, you know, we have, you know, clear raw materials from, you know, Pennsylvania, New York. And what we also have here is, you know, stone tools are being made, but they're kind of coming into the site, you know, already in decent stages of reduction. So they're not actually making the blanks, you know, here. And so that's kind of a really kind of cool analysis that shows, you know, stone tools are not just, or lithic technology is not just about these stone tools, which are cool in their own right, but from kind of this debitage, this sort of garbage, if you will, we can actually learn a lot about the manufacturing process, and also too about sort of mobility in the past. And one of the other things that I'll just quickly discuss here is this idea of lithic refitting. And so as Dr. Leslie was talking about, there are times when you're making a stone tool and, you know, this is something you've spent a lot of time on and you're almost done and it breaks and there's nothing you can do about it. Life happens. And what we can do sometimes though, is we can see if we can find the other part of that broken stone tool. And what I just have here is we're doing some preliminary analysis on these sorts of refits. And in this case, this is just sort of a diagram of different refits of these channel flakes. These were the things Dr. Leslie was talking about, the sort of final stage of these Paleo-Indian projectile points. And so these, you know, frequently break in this final stage. And what we can see here, and this also kind of speaks to the integrity of the site, is we actually have like refits. And we can sort of see that, you know, some of these refits are close together. Some of them are a bit further apart, but you know, they're definitely there. And because of the slow depositional nature of the site, these refits probably indicate use of space. You know, this isn't just like these things have been moved by the river or anything like that. So it's really kind of cool to see how these items move around the archaeological site, you know, and how people have moved them around the site. And then one of the final things that we're going to, or that we plan to do, is sort of do a bit more analysis on the raw materials. And one of the things we're going to do is we're going to try to figure out the source of the raw materials. So overall, in a way that's sort of been answered. But one of the more important things is this idea of this yellow jasper here. This stuff is, you know, usually from Pennsylvania, but we found pieces with cortex on them, which would seem unusual based on sort of what I've just been talking about for them to have cortex if they're coming from that far away. And so what we're wondering is if there might be more local sources for this jasper. And, you know, it could be that there's river cobble deposits in the Berkshires nearby Robin Swamp, maybe even in the Farmington River itself. And, you know, it would be really interesting to see if, number one, we can find these local sources of jasper, and number two, see how it actually compares to what we have at Brian Jones. I have no doubt in my mind that a lot of this jasper is in fact from Pennsylvania, if not most of it. But if we could, you know, confirm that we also have more local sources, it would be interesting and valuable to see that we can actually tell the difference between the two. And that would tell us, that would potentially provide valuable data on mobility, because there's a huge difference, I would say, between, you know, trying to understand how Paleo-Indians moved around, you know, if they're using stuff from Pennsylvania versus from, you know, the Farmington River or even from the Berkshires. So all of this sort of stuff is a very indirect way of figuring out how people are moving about the landscape. And, you know, just to sort of wrap up here, you know, the micromorphology confirms the integrity of the site and how it developed. No doubt the lack of floods made it a great place to settle, which is why people kept coming back to it, you know, time after time after time. The results on the pendant are definitely illuminating. It's great that we confirmed that the pendant was, or the perforation in the pendant was created by people. And, you know, our future sort of lithic technology work will sort of focus on tool maintenance. You know, will basically show how people were manufacturing tools. And based on the limited information that we have now, it sort of seems like there's a focus on the tool maintenance and use, and these use of these non-local raw materials. And, you know, just acknowledgements, just like very much like Dr. Leslie had, Office of State Archaeologist, everyone at AHS, of course, CONDOT, Geosciences, CT SHPO, Rotha Construction, the town of Avon. And also, I'd like to personally thank Dr. David Leslie, because, you know, he's sort of, you know, clued me in on all of the research that's going on and sort of has helped me out as he's handed research off to me. And so, yeah, that's all I have.
All right, and we have some good questions coming in. Okay, the first one, can everyone hear me okay? Someone wrote in and said they just wanted to know if both of you guys were aware of the mastodon skeleton that was discovered in the Hillstead Museum grounds in Farmington, Connecticut in the early 1900s. This site was within a few miles from the Farmington River site that we're talking about today. It could be relevant since you mentioned that protein from an animal in the elephant family was found at the Farmington site.
So yeah, it's a great question. And as somebody, I think Tina maybe or somebody else has mentioned, there actually was a great presentation about this by the current state archaeologist, Dr. Sarah Sportman, and a companion presentation by Dr. Nathaniel Kitchell earlier this year about Ice Age mammals, specifically mastodons and mammoths, the Farmington mastodon by Dr. Sportman, and the Mount Holly mammoth by Dr. Kitchell, which is in Vermont, which was found in Vermont. Yes, we are both, of course, aware of the Pope or Farmington mastodon, as it's been called. What's interesting is that Dr. Brian Jones and Dr. Michael Bollinger actually radiocarbon dated that mastodon to about 14,700 years ago. So it's a bit older than the occupations that we have here. And that's sort of what the story was for a long time, that these Ice Age mammals, not in the rest of North America, but here in the Northeast, appeared to go locally extinct before people were in the area. And that's because the glaciers here sort of kept people from being in New England during that time period, 13,500 years ago, when it's clear that Paleo-Indians and much of the rest of the country, while they probably weren't hunting mammoths and mastodons all of the time, they were doing it sometimes. But here, until about 2 years ago, it was unclear if in New England people and mastodons and mammoths ever overlapped. The work by Dr. Kitchell on the Mount Holly mammoth clearly shows that they did, because that mammoth has been radiocarbon dated to 12,770 years ago, which is within the statistical date range of feature 15 from this site. Fortuitously, later that year after his publication, we discovered that that large scraper had elephant blood protein on it, confirming that a scraper was used to scrape an elephant hide here in Connecticut. As Dr. Heffter mentioned, it could be a mammoth or a mastodon, although I will say that only mastodons have ever been found in Connecticut. And that's because the vegetation here in southern New England was somewhat different than the steppe sort of grassland that you see in northern New England at about 13,000 to 12,000 years ago. So mastodons were most likely what were here and what people butchered at the site. So that's a very long-winded way of saying, yes, we are aware of it. And if you're interested in Ice Age mammals, you should look back at the presentations by both Dr. Sportman and Dr. Kitchell from earlier this year. They were both really excellent.
Correct. And they're right on our YouTube channel. All right. Next question from the audience. What type of stone is the pendant made of?
So Eric, do you want to answer that one?
Well, I actually don't remember offhand.
Oh, sure. It was hornfels.
Yeah, that's right.
It was made from hornfels, which is a local material that's found, we think, in Suffield, Connecticut, although there could be outcrops farther south too. I think it's like the 4th or 5th most common type of stone tool that we have at the site. And it seemed to be used mostly for tools, but here it was also used to make a pendant as well.
Okay. Next question from the audience. Does site evidence suggest which seasons the camp at the Avon site was used?
Yeah, in the presentation last year, it was discussed, but basically, you know, we have pretty good evidence of occupation in the summer and the fall, and also some perhaps in the spring.
Okay. And then back to a site-specific question. Any thoughts on the purposes of the post holes? Are they a shelter structure? A hide stretching rack? Are there any theories on the types of shelter used in this period before the woodland period Quonset huts? Thank you.
Well, Dr. Leslie and I have been sort of talking about this, and I think that, he has some pretty good thoughts about it.
Sure. I mean, I think that it's possible that some of the structures, some of the post holes could be used for hide stretching. However, I think it's more likely people live in houses, and they did so in the Paleo-Indian period, as they did in other periods as well. And many of the post molds are in diagonal directions, pointed not in the same direction, but converging directions near a hearth. The hearth is not necessarily within the confines of those post molds. However, it is near it. And if, as Eric was just mentioning, we have very good evidence that many of the botanicals suggest berries and seeds that would only be able to be harvested in the summer or the fall. Again, we're not really sure when some of these plants might have been available, because the Pleistocene is a very different environmental regime than what we have today. But based on when strawberries or cattails, those types of plants are available, I think that we have a good handle on that. In the summers in New England, even during the Pleistocene, it would have been warm. So there's no reason that the hearth should be inside of a structure. That's not what you would expect in the summer or the late fall. You would expect the hearth to be on the exterior of the house, and it's probably a temporary house, one that could be taken down and put up with very minimal effort, sort of like a tent, but one that you might reside in a location for a week, maybe 2 weeks, maybe 3, maybe 4, but probably not much longer than that, based on how nomadic we think Paleo-Indians might have been during this period. So we think that there's good evidence for a house. There could, of course, be, we could be wrong. It could be some sort of hide stretching or hide drying location too. But those are really the two main things that it could be. It's hard to imagine a different kind of structure at this time.
Okay. And we have a couple more audience ones, and then I know Terry has some questions as well. Has any pottery been found at the site?
No, I mean, there's been a lot of cool stuff found, of course, but pottery occurs much, much later, many thousands of years later. And in fact, the woodland site that was found on top of it, I mean, I cannot remember if it contained pottery. I'm guessing that it probably did, but the Middle Woodland period definitely has pottery. So pottery is an advent that comes much, much later. And also too, if you think about it in the context of different kind of levels of mobility, Paleo-Indians are moving around quite a bit. And so, you know, something like a very large ceramic vase or whatever, that's not going to be super conducive to, you know, moving around a lot. And so pottery can correlate sometimes with sort of being more sedentary. And so pottery is just something that occurs much, much later.
Okay.
Yeah, and people cooked in probably animal skins. They would make stews in animal skins, and they would add boiling stones to those skins that held water and the stews that they were making to heat those skins up. So it's a more efficient way of cooking if you're going to be moving around a lot, like Eric was talking about.
Okay. Another site-specific question: besides charred pine, what other woods, if any, were found?
Oh, well, I mean, that's actually one of the cool things, is that we do have a lot of different botanicals, but in the context of wood, we have such things as oak, pincherry, maple, dogwood. You know, so what we're seeing is not just sort of, you know, pine. You have these more deciduous trees coming in, which tells us kind of a lot about sort of the paleoclimate at the time. There's sort of this idea that, you know, because of the cold temperatures, that, you know, it's probably going to be more boreal forests or things like that. And what we actually see, at least at the Bryant Jones site, is a more sort of varied forest that was available. I mean, for sure, you know, pine is there. In fact, I think it is the most numerous found, but we do have this input of deciduous trees. So that shows that there is kind of a breakup, and it's not just this strict boreal forest.
Okay. Any thoughts on the source of the ochre?
Yeah, what a great question. It's a super complicated question too. Here in New England, we have very iron-rich soils. Ochre is, so we didn't talk about, Eric mentioned a little bit, our ability to source where stone tools come from is very complicated and very difficult to do. It's best with volcanic materials because a volcano eruption has a sort of geochemical signature. Chert and hornfells and those types of materials have geochemical signatures, but they vary spatially over small distances. Ochre is the same. It's formed in a sedimentary environment from compression, from iron-rich sediments. Almost all of Western Connecticut is iron-rich. If you heat those soils to a certain temperature, you will get an ochre-like substance. For it to be ochre, it just has to be a discrete nodule that is hematite or red or yellow or a couple of other colors and streaks when you apply it to a surface. And so, in fact, many of the excavations that we've done have shown that when you heat soils in, say, northwestern Connecticut, where you have an open air hearth and it gets hot enough, you can get these sort of like red pavements of soils around the hearth where ochre has been created. Is that intentional? Is that just a byproduct? It's probably both, right? That's not what happened here at the Brian Jones site. We saw nothing that suggested the soils that were heated here created that sort of pavement of ochre, but it does suggest that people could intentionally heat soils in iron-rich sediments and create ochre, take that ochre with them and use it. They may also have just known where to get the ochre as well, which is what happens in other parts of the country, we think. But it's a very complicated question with no easy answer. And it sort of dives into how complicated some of these analyses can be based on trying to geochemically source where this stuff comes from. It creates more questions than it answers, but we do know that it wasn't created at the site, and therefore the best explanation is that people either created it someplace else or harvested it someplace else and brought it to the site.
Okay. And then this last one before Terry does hers, are sort of speculative in nature. If this site was occupied for thousands of years, they're wondering whether the occupants might have evolved into a prime or rich, or rich is not probably the right word, but in terms of the socioeconomic base, can we speculate anything culturally on the people who return to this area year after year?
Well, I mean, I think it's one of those things where, you know, because of the lifestyle that we live, it's like just really hard to conceive of like sort of a hunter-gatherer lifestyle. It's one of those things where, you know, people like talk about, but even, for example, the question of pottery just sort of shows, you know, how we don't even necessarily have like the mindset, because you would think like, yeah, I'd want tons of stuff to like, you know, like cook stuff in, but something like pottery would not be a good thing. As Dave mentioned, you know, like, you know, boiling stuff in hides would be much more efficient and much more useful. And so I think I understand sort of what the crux of the question is. I guess my comment would be, you know, in terms of like us humans, Homo sapiens, you know, we emerge in Africa, let's say 180, 200,000, maybe even a little later than that. I firmly believe that even though that is a long time ago, that those are people that were just like us. And so certainly, you know, the Paleo Indians that were here are just like us. They are us, you know, there's not really anything different about them. So in the context of sort of socioeconomics, I think what I would say is that because you have people moving around, you don't have people staying in one spot, which means that they can't really accumulate goods. And therefore you kind of like have less of an ability to kind of create inequality or sort of a power dynamic, you know? And also too, you're dealing with really, really low population densities. And so in terms of competition for resources, it probably would not have been much of an issue. So there are for sure examples of hunter-gatherers that manifest inequality in different ways. So, you know, for example, in Australia, traditionally the hunter-gatherers there, hunter-gatherers are largely viewed economically as egalitarian. They don't really have many possessions, and there's usually sharing of goods and resources among groups. but you have inequality manifesting in other forms, let's say gendered inequality, age inequality. So, you have older people maybe making more decisions than younger people, things like that. And so I guess what I would say, it's a very long-winded way of saying, while this would have been a good area to return to and inhabit, it wouldn't have been, let's say, something that would have been fought over or intensely guarded. And I personally don't think that you would have seen sort of, different levels different levels of power or prestige or socioeconomic status in the hunter-gatherers that are at Brian Jones compared to other hunter-gatherers that are on the landscape.
I like this. That was a very layered answer. Thank you. All right. That is the end of our audience questions. Terry, did you have any questions? And did you want to do our final closing thoughts?
I do have a couple of quick questions because some things have come up over time, and I just want to ask these because we're at the update point. I think Dr. Heffter just talked about the amount of people, that these were not huge groups of people, that these hunter-gatherer groups that came in and out were small. So I believe maybe Dr. Leslie mentioned a year or so ago that it was Brian Jones himself who was working on a theory of numbers of people. Just curious if anybody else is working on that. Has that topic ever come up again? That's one question that's come up. But I think, is there any more?
Well, so John Lothrop, when he gave a talk earlier in the year, mentioned that Brian was one of the only people who had published a paper about social networking and the size of Paleo-Indian groups in New England. There have been other attempts at size of groups at New England Paleo-Indian sites, but not from a social networking perspective. The Bull Brook site, which was reinterpreted by a couple of archaeologists, Jennifer Ort, Bert, I'm going to pronounce his name wrong, Bert, I'm not going to say it right, and Brian Robinson. That's a site that provides a lot of similarities to Avon in that there were no cultural features preserved, but they used the artifact distributions to determine or predict how many people might have been at the area based on the rings of artifacts around cultural features that would have been there but have since eroded away. We thought initially that Avon might be very similar to that. What we found instead is that we see repeated occupations, not one large communal occupation, as was interpreted at the Bull Brook Paleo-Indian site. And so while we can test some of those assumptions about artifact distributions around campfires or posts, like was predicted at the Bull Brook site, I don't think that we're seeing something similar to that at all. A large aggregation site or a place where people are coming together in, say, an important season, that makes sense. I mean, I don't think that they are wrong. I think that would have happened over and over again. Different groups of Paleo-Indians or people in the early Archaic would have come together from their different sort of small family-sized groups where they come together. There's a good location at the river where everybody knows where it is. You hunt caribou together. The Templeton site might be a good example of this. Those make sense. I'm skeptical of ideas that make sense from an archaeological perspective, though, because we're often wrong when we try to interpret things that far removed from the present, as Eric was talking about, but they make sense. But our radiocarbon dating here has shown that instead of one large communal site at one period in time, we have a bunch of occupations over 4,500 years, right? That doesn't mean that outside of the site that was excavated, we might find other Paleo-Indian occupations or other early Paleo-Indian occupations. That could be what we would find. But so far, based on the stuff that's been excavated, I would say that it's more likely that we have small groups of people where it's difficult to predict how many people were there, but probably family-sized or a couple of families and no larger than that.
Yeah.
So no, nobody's been doing that work that Brian was working on, really.
Okay, and then your LiDAR picture at the beginning, which showed the was it 700 meters north or whatever that could possibly be part of this site. I'd like our viewers to understand that, because this question has come up a number of times. why did they only dig in that one spot? But you were kind of confined to what the DOT wanted you to do for the bridge. And right, I mean, you really couldn't just keep going north and keep going. I mean, now you have with the samples and all that you have. But so this site is just not, you're pretty sure this site is not confined just the space that you showed us. It really is much farther, probably north and somewhat south.
We think so, based on the data that we collected. And you're right. The compliance-driven work that we did with the Connecticut Department of Transportation is necessarily constrained to where the impacts are, because archaeology is destructive. The more you excavate, the more a site you destroy, right?
Yep.
We endeavor to record as much information as possible when we excavate a site, but it is destructive. We remove artifacts from where they are in the ground. We remove their context. And so the compliance work that we were talking about, while it is research driven now, we're doing a number of really interesting and great research on those artifacts. Again, completely funded by the Connecticut Department of Transportation. We did not expand beyond the footprint of the development, because that would be, an impact to the site that is unnecessary. It's better to preserve it, to let future archaeologists come in, have other questions, ideas they want to excavate, or simply preserve it because it's an incredible resource that deserves to be preserved.
Right, right. And the last question I have from somebody is climate change. Were you able to tell over the 12,000 years if there were other climate changes, and how did you analyze that from the site, or were you able to?
Sorry, say that again.
Were there climate changes during the last 12,000 years that you could find in that site? Was there a way to do that?
Yeah, Eric alluded to some of that. So there are clear evidences of climate change during the Pleistocene. So it's a colder period versus the Holocene. During the early Holocene or the early Archaic period, it's getting warmer. And so there are changes that we expect based off of pollen data that's been collected throughout New England about the vegetative regime that is here in New England. As it gets warmer, we find more deciduous trees. However, during the Middle Paleo-Indian period, there is a cold snap that happens. It's known as the Younger Dryas. The Younger Dryas is a complicated climatic event to understand and to diagnose at these types of sites. But it's basically understood to be a cold snap where the climate has been sort of warming towards the end of the Pleistocene, and then that reverses and it becomes colder. And what's really interesting is that we do see some deciduous plants during I believe the early/middle Paleo-Indian period, in the late Paleo-Indian period, in the early Archaic period, and maybe even in the early Paleo-Indian period, although I'm not sure of that. But in the middle Paleo-Indian period, right in the middle of that cold snap, we don't see any deciduous plants. We see only those boreal forests, suggesting that those more temperate plants are being affected. Again, this isn't like a pollen. What we're seeing are the things that people brought back to the site, right? So there is another agent there. It's not a geologic window or an environmental window. Humans are modifying the environment, bringing those things back to the site. So it's not a perfect indicator of what the climate would be. It is an indicator of people's preferences for their firewood, which can be a lot of things. It can be that people wanted oak or maple to smoke their venison or meat, right? There are a number of choices that people make when they build a campfire versus spruce or pine, which burns hotter and faster, right? There are a number of choices people make. However, we think it's telling that in the Middle Paleo-Indian period, we see none of those other deciduous plants, suggesting that it is getting colder and that's been borne out in the Middle Paleo-Indian period, in that Younger Dryas.
Okay. All right, well, thank you. If I can do a little closing, I'd just like to say, first of all, thank you again for coming tonight to, to tell us all about this. But I also would like to encourage our viewers, if they're in Connecticut or in the area, in the region, to visit one of our partners, which is the Institute for American Indian Studies in Washington, Connecticut, and the nearby Templeton site, which is an area that you can go see. And the museum has a lot of information about the whole indigenous population in Connecticut. And it's very helpful to kind of put it into time frame and time period for you. And it's available. The Templeton site is just a little bit younger than the Brian Jones site, but they're both Paleo-Indian sites. There may be more, as these gentlemen have talked about tonight in Connecticut, that may be found, but they are a partner with us, and we're pleased to be able to send people to their museum and to see what they have to show, because we will not have anything available until 2024 when we open a museum to Avon's history, and we will have a section set off on the paleo part. So we'll have more about it then. So anyway, thank you very much, everybody, for sticking with us tonight. And I know it's been a long evening, but we appreciate it. And Tina, it's yours to close up.
All right, thank you, everyone. We'll get the video recording ready, and we'll see you all again for the bonus programs at the end of this year and next year's 2023 series. Thank you, everyone.
Bye.